so much, Professor Colin, for your kind invitation, and thanks very much for hosting me. Let me share my screen. Can you see my screen and hear me? Great. Thank you so much. So it is really a great pleasure for me to present developing AI within emergency medicine. So without further ado, let me go to the first slide. So why do we need artificial intelligence? So AI is something not really new, has a long history of more than 70 years, but AI has been extremely popular in healthcare nowadays and also in emergency medicine. So in my personal opinion, that AI is something that's data-driven. And this is the motivation for using AI is because of the availability of a massive amount of real-world data. So real-world data comes from disease registries, from electronic health records, from administrative and healthcare claims data sets, from wearable sensors, from anywhere, even from your smartphones, right? There were tons of real-world data comes up. So that is the motivation for people to think about whether we can get insights from real-world data, and that leads to the definition of a real-world evidence. So which is the clinical evidence regarding the usage and potential benefits of risk or medical product derived from the analysis of real-world data. And this is indeed the real motivation and driving factor for the adoption of AI for healthcare and of course for emergency medicine. If we look at this figure, and it is depicts about the data availability of different phases of trials. For example, in traditional clinical research that we look into phase 1 to 3 trials, where that we can simply use a traditional statistical analysis methods to analyze the data. But when it comes to the post-approval stage, where that you have access to a population data, which actually only account for a small part of the real-world data, where that we have access to many different data from various sources. As I mentioned earlier, that you can get your data from wearable devices, you can get the data from surveys, you can get the data from smart devices that those devices collect your data even that you are not aware of it. So these are the form a huge pool of data that's available for us to make additional analysis and to get the insights in order to understand the efficacy of a drug or the effectiveness of a device. And coming back to the topic of AI, so AI actually has a very long history, right? That can be traced back to 1950s. So the first concept of AI actually was developed even before the invention of modern electronics computers. So in essence, AI is refers to any technique that enables computer or a mechanics or device to mimic human behavior. So after the invention of the artificial intelligence, there has been some peaks and the valleys, right? There are ups and downs in the development of the whole AI history. That because of the limitations of computing power, so people has been only focusing on deriving some concepts about the artificial intelligence until the 1980s, when the modern computers becoming popular, that people start to look into computer algorithms, which often refers to machine learning methods. So these are the AI techniques that give computers the ability to learn without being explicitly programmed to do so. So with machine learning methods, so we can easily achieve many goals of artificial intelligence, whereas AI is more like a concept, but machine learning is the real things that behind AI. And within machine learning and AI, there's a specific topic called deep learning, so which can actually also has a long time of development, but getting very popular in the recent 10 years because of the popularity of modern GPU, those graphic computing units that becomes easier and cheaper compared to a long time ago. That people start to looking at the solutions of using deep learning for analyzing very large scale data that cannot be easily analyzed in the past. So AI and machine learning explore the study of algorithms that can learn from data, and they actually belongs to a broader domain of computer science and have a very strong relationship with traditional statistics and mathematics. Sometimes people may refer AI to predictive analytics or predictive modeling. But in our daily life, AI is everywhere, right? You can, people use AI for search engine, use AI for stock trading and scientific discovery, those are protein structure discovery, all based on AI nowadays. And other than performing as a general analytics tool, the AI has also, different, very specific domain of research and application. So one such application and method is called natural language processing. That with the AI techniques, you can analyze the speech, audios, and text. And of course, AI has a huge branch of computer vision and understanding that in medical domain, so people has been using AI for analyzing two-dimensional or three-dimensional medical images for addressing many of the clinical issues, particularly for radiology. That AI has the capability of information fusion, meaning that you can combine multimodality data sources that includes free text, image, and tabular data, so many things together and feeding into a unified AI model for decision making. So these are the most commonly used AI techniques for addressing some specific problems. So within healthcare or even beyond healthcare. And these are the brief categorization of AI methodologies. You can you can name it deep learning, translation, information extraction, or machine learning, natural language processing, expert system. There are many different subtopics within the artificial intelligence research, and many of the techniques actually are readily available for healthcare applications. So just now I give you a very brief introduction to artificial intelligence, and next I will also briefly share with you some AI applications in emergency medicine, and some of the examples comes from my own research. So I did a simple review a few years back that briefly summarized. So what happened in the emergency medicine? Are there any solutions or applications that people use AI for emergency medicine? So in essence, that we summarized, there were three groups of research, right? So predictive modeling, patient monitoring, and operation optimization. So these are the three major groups within the domain of AI for emergency medicine. But of course, so these three categories are interrelated with each other. For example, in optimization of the operations, people use AI for prediction, and also they use AI and some sensor technologies for patient monitoring. So all these are interconnected. So next, I will give you a very simple story about how to use AI for ED triage. As you know, that ED triage is a very important step in the management of an emergency department. But unfortunately, we have a very limited medical resources and limited number of doctors and nurses and medical facilities in the emergency department. And if we can have an accurate triage, that potentially can be very helpful in guiding the medical decision making. But in most of the emergency departments worldwide, so this triage is generally done by nurses and doctors based on their own personal knowledge and the experience, and also the patient's presenting symptoms. So there were drawbacks, right? So for example, the symptoms that the patient presents may not be a real reflection of the condition of that patient is facing. So what we need is really an objective, fast, and accurate risk stratification tool that can be used for AI, for ED triage. And then we think about whether the AI can do this. Motivated by the large data that we have access in the Singapore General Hospital, we developed this called the Score for Emergency Risk Prediction, SERP, as a triage tool for estimating mortality risk for all emergency admissions. So as you can see from this table, there are 3 clinical scores. So for the orange blocks highlighted, one of them, so it is called SERP 30-day, means that this score is mainly triage tool for prediction of a 30-day mortality for patients who visit emergency department and were subsequently admitted. Apparently, even though this score was developed by the use of AI and machine learning methodologies based on the big data, the output of this AI model actually is fairly simple. That is why we call this type of research as interpretable machine learning for clinical decision making. So ultimately, we want to have something that's interpretable, simple, and easily be adopted in clinical ground. So look at this score. So there are only 5 variables, including age, heart rate, respiration rate, BP, and cancer history. So with only 5 variables, we're able to achieve a quite good performance. So these are a little bit details about the process of developing the SERP triage score, that we feed in some candidate variables such as the demographics, so ED administrative data, and some clinical data, so even including blood test results. So overall, we included more than 360,000 emergency admissions in the data set that we obtained from Singapore General Hospital. And ultimately, so this table shows the performance. So we did a comparison between this SERP score versus some other clinical scores, for example, MUSE and NEWS, and RAPS and REMS, and plus PACS, which is our own triage scale that's nationally implemented in all Singapore public hospitals. So apparently that this our new score performs the best in terms of the accuracy and also sensitivity and specificity. So given that we have such a model, how can we use it, right? It is a very important question. So a useful tool for risk stratification, right, which is reflected as the better performance in terms of accuracy on predicting mortality risk. But whether or not this is a good tool, we will still require some randomized trials or probably observational study to have a further investigation. And of course, I mean, if we identify patients with a higher risk, we probably can suggest an ICU admission. And for those lower risk, we probably can suggest for discharge from the emergency department. But again, the score has been developed, but how to use it is another story. It involves in a lot of clinical inputs as well as a rigorous evaluation through the implementation science methodology and evaluation metrics. So other than that, so we also did some other triage exercise for using medical devices. So this is particularly we look into a triage of chest pain patients, which account for a small portion of all ED visits, but potentially could be a very important group of patients because many patients present with chest pain to the ED may or may not present adverse cardiac outcomes. Right? Some patients may, just present with a very minor issues, but some patients, even the chest pain, the symptoms is minor, but the outcomes may be adverse. So in this study, so we particularly designed a medical device for getting the data from the patients, and through some machine learning and signal analysis methodology, we developed an AI-based risk scoring system that can be used for risk stratified chest pain patients in the ED. So this figure shows a very older version of our device. And in the past few years, roughly 7-8 years, we have been developing several versions of the device. And this is the latest addition, where that we have a palm-sized device that can be linked to a tablet. So every AI component and the data processing can be done within the tablet or any smart devices. With this, even without blood test results like the troponin value, we will still be able to achieve a very good performance of risk prediction within just 5 minutes of patient data collection. And this could be something interesting that I'm not saying to replace the traditional clinical pathway for chest pain patients, but this can definitely be a solution to accelerate the traditional pathway. And of course, I mean, in terms of triage, there are many other options that we can, a condition that we can consider. So I think our speaker just now mentioned about the ED faces, many different types of patients, and usually our clinicians have a very diverse research interest. So that's actually provide us a very good opportunity to look into a variety of conditions. Like we can look into a sepsis risk prediction, we can look into a trauma or heart failure risk prediction, atrial fibrillation. So there are different types of research, and that's really, associated with your personal interest. But overall, that our team has been primarily focusing on the methodology development that can potentially be applied to different conditions. So I think ultimately we want to really push the patients back to the pre-hospital, ultimately to the community, where that wearable sensors and mobile devices could be a solution, where that we can tap on the AI and big data for some risk stratification even before the patients visit the emergency department. So one last example is about the AI for emergency medical services. That's Quality Intelligence Assistant, which is a system that has been implemented in a Copenhagen EMS system, has been successfully be validated in identifying whether the patient is having cardiac arrest or not. So this quality system actually use speech analysis algorithms together with AI to analyze the signals in verbal communication, tone of voice, and breathing patterns that's obtained through emergency calls. So it is very interesting and it's very meaningful, because I think this quality system is one of the first AI engines has been implemented in real world, so in emergency care. So I think this is something quite interesting, and I believe that in the future there will be more and more such innovations available in emergency medicine. So the last one I want to share is about the optimization, right? So this Optimal Product is a commercial company that produce solutions for data-driven decision, where that's one of such a product is about using AI for optimizing the dispatch of ambulance, where they gather information from a traffic, from the ambulance, from a patient condition. So from various data sources, so this AI engine is really can read the data, get the insights, and provide an optimal route for ambulance and dispatch, and also for patient care. So there will be many other more applications. So I'm here just to share a little bit on a small portion of application where that we can use AI for emergency medicine and emergency care. Now, of course, there were challenges. The biggest challenge is the data, right? So we need to have high quality data, and also we have to combine the data with domain knowledge in order to deliver insightful and meaningful research in emergency medicine. So other than that, interpretability is also important. So AI is good at a black box, but there has been a trend of interpretable and explainable AI, where that people trying to decipher the black box in order to provide something that clinicians can understand. So of course, the last part is the privacy and regulation. So since AI deals with the big data, so people concerned about the privacy, and also the regulators are also concerned about the privacy and the data security issues. So I think the AI is definitely will play an important role in future emergency medicine. So here I only share a little bit on my own story and some of the story that I know. If you have any good idea, welcome to send me an email, and I'm very happy to share more with you, and I'm happy to collaborate if there is any opportunity. Thank you so much.
Dr. Liu, thank you so much for that. That was a fascinating talk and very up to date. We've got a couple of questions, and I've got one as well. So Dr. C.T. Loy from Toon Moon Hostel has written, I'm sure you can see it there, what's your view on external validity and generalizability of locally trained AI deep learning models with the issue of overfitting?
Yeah, exactly. I think this is a very good question. That is actually happen all the time, that you develop one model which performs very good in your local setting, but this generalization in another setting is not that good. So I'm trying to share some of my personal views. So I'm thinking that a model is always good for your local use. So it's not necessary to really, your model will still have a super, high performance in another setting. But in terms of your local setting, you need to carefully design and validate your model. Let's say if you use, your first 5 years of data to develop your model, and then you probably can reserve some of the new data for validation. If your internal validation, meaning that you use your data from your local setting, is good enough, means that there's a lower chance of overfitting. But if your validation on new data is not good, means that there was a certain level of underfitting or overfitting. Then you have to retrain your model to think about whether additional parameters and the variables are valuable. But coming to the question of whether the generalization to other settings, I think is everybody wants to have a very good generalizability of your own model, but no one can guarantee about that unless the settings that's in another country is quite similar to your own setting. Then likely that your performance will be good. Otherwise, I think there will always be expectation of a lower performance in a different setting. Yeah.
Good answer. I mean, I think it's interesting that this features so prominently in the AI big data world. I mean, I think back to when I was training, and one of the first rules Tim Rayner mentioned, Ian Steele in the Ottawa ankle rules, the Ottawa knee rules, which were very generalizable. But the one I always remember was the San Francisco syncope rule. Long before AI, of course, but the famous thing about that was, of course, it was only applicable to San Francisco. It was never shown to work in any other place on the planet, which was a real shame for them because they'd done some great work. But it ties in nicely with what you said. So this is not new. It's just we're seeing it even in the presence of huge data sets and the additional layers of AI.
Yeah. Sorry to just one more point
Mm.
regarding this question. So I think because the availability of big data nowadays, so you know in your own hospitals you have access to a very good high quality data, then that is motivation that our own research actually focusing on a standardized methodology for model building and evaluation. That means that for your local setting is rather than using other people's score or prediction model, then if there is a standardized approach for model building, then you probably can use the same methodology and use your own data to derive something that can be tailored for your local setting.
That's very useful. I mean, that ties in the CT that I spoke to us a few days ago on the big data set up in Hong Kong, particularly in the emergency departments throughout the territory, and how that's going to expand over the next few years. And as you suggest, having a standardized model building process would work very well as more and more clusters and hospitals come on board with that process.
Yeah, thank you.
Kevin also has a question. How can EM researchers learn about smart technology to improve our patient care?
Oh, so this is a huge topic. So smart technology is usually, I mean, you can say it is a device or it is a AI. I think from my background is in electrical engineering. So I spent about 10 plus years in emergency department. So I'm not a physician, but I know a little bit on a clinical side. So I do not recommend that emergency medicine researchers to really learn the details of a smart technology and AI. But one thing that EM researchers should learn is how this technology can help. With, for example, the AI, as I mentioned in the slides, AI can be used for analyzing free text, analyzing speech, can analyzing image, and can make a prediction. So these are the important information that the EM researchers should know. In terms of the very detailed methodology, I don't think it is necessary. So the best option, at least based on my experience in Singapore, is that the EM researchers always collaborate with a computer scientist or electrical engineers to deliver, clinically meaningful solution for improving patient care.
Very good advice and something we should follow up on. It struck me listening to your talk that you mentioned about real world data, but it's certainly in our setting about real time data and how, and as you say, how we integrate that with the monitoring of patients and the alerting to identify those patients, as you highlighted, who are in the high risk groups. My final comment, just before we move on, is data is clearly critical and we're focused on data, but we're all brought up to also have that clinical intuition, and or if you like, gestalt. You put your hand on the patient, they're a bit sweaty, they're a bit cool, they're not quite right, and I always call it the end of the bedogram. You're standing there just looking at the patient saying, you're not right. How do we integrate these subtleties with the data-driven process that you've outlined? I mean, Mikkel will talk to us in a minute, and I'll introduce him just in a second, but we've done some work with Mikkel looking at thermography, for example, to look at things like peripheral temperatures. And I don't think it clearly has utility. The question is, how does it fit into the process, for example? And I'm curious, it ties in nicely with your final couple of slides about the Corti AI system in Copenhagen, I would think. What's your view on that?
Yeah, so exactly. So I think AI is something, somebody call this AI is objective, right? So it is a purely 100% data-driven thing. Means that if you feed in the AI with some data that are not so reliable, then the model that AI builds is not reliable. That is a reflection of the inputs. So the key that's in AI is really a combination of data plus clinical inputs. So it is not purely not a drop by data scientist. It is dropped by a data scientist and an emergency physician. So in terms of the integration of those while standardized data inputs, I think if you can quantify those measures, you would definitely want to put them into the AI model, right, to build up the model for prediction or for risk assessment. But if you couldn't, so usually, I mean, people will consider AI, this a data-driven solution, as a assistant, similar to this or COTI assistant. So the ultimate decision will still be with a clinician. So if AI tells you this patient is okay, but as a physician, you feel the gut feels is that, oh, this patient probably has something wrong, then you shouldn't listen to the AI. And at least AI could be providing a second opinion, but we were not confident to really rely on AI to make any clinical decision.
Fascinating. Thank you very much indeed, Dr. Liu. That was brilliant. And it's safe to say many people will be in touch with you after a talk like that. Your final conclusion that the best combination is an emergency care provider, an emergency specialist, and a data scientist leads us on beautifully to our next speaker.